Good morning, good afternoon, good evening, everybody. My name is MC Brown. I'm VP of Product here at Continuent, and welcome to the webinar today. Today we're going to be talking about Tungsten Replicator and replicating data out of Oracle and MySQL into Elasticsearch. A few points of order before we get started. This webinar is in fact being recorded, so if you want to come back and view this at another time, you can certainly come and do so. We'll make the recording available once this webinar has been completed. You'll also notice that on the control panel for the webinar, there is a questions section. If you have any questions, please feel free to answer them. I can't guarantee I'm going to be able to answer them in the presentation. Obviously, it's going to depend on you know how the presentation works. You know, let's get started. Start having a look at Tungsten Replicator and Elasticsearch. So we're going to go through a few different things today, obviously related to the way Replication and Elasticsearch work together. So we're going to first of all just have a quick look, why you might be using Elasticsearch in the first place. So I'll describe a little bit about what Elasticsearch is and a little bit of the background. Then we'll move on. We'll have a look at how replication into Elasticsearch works. So obviously there's some basic items about how the replication works, and obviously you know, some of those items will be the same. If you've seen some of our other webinars, you'll be able to see how that operates. There are also obviously some differences. We do some things that are unique to the Elasticsearch experience. And then we'll have a look at, you know, some ways in which you can change the way that information is organized. And then ultimately we'll have a hopefully a quick demo, and then we'll have a quick look in and see what else we're doing, you know, both with the replicator generally and also specifically with what we're doing with our Elasticsearch applier. So first question, and probably one of the more important ones to answer, is why you would use Elasticsearch in the first place. Well, you know, Elasticsearch itself is a database that has been highly configured and organized so that it can store information in a very, very efficient manner for the purposes of either handling search, which is obviously where the name comes from, or for handling kind of analytics aggregation style material, and both of those are actually in some way related. So from the search angle, one of the things that you can do with Elasticsearch is if you've got an application, you know, website in-house, etc., you want to be able to provide a searching mechanism and even a free text searching mechanism, but then you want to be able to take that information and very, very quickly provide search results. You could do that with Elasticsearch, and then once the results come up, you use the source information, the identity of where that search information came from, to be able to redirect someone back. So let's say you're selling, you know, you're selling products on your website. You have a search that you can go in and look for stuff. You could use Elasticsearch to provide your search, but when someone actually clicks on the product, you redirect them back to the original database if you want to, so that they get the full detail. And Elasticsearch operates on you know, a very, very simple way of updating and storing that information for getting that data in, so that you can use it for the search. And that's all based around you know, a REST-based API for getting that data in. That means that, you know, from the outside, you know, it's very, very quick to be able to get the data into Elasticsearch, and obviously that's critical for any kind of searching system. It also very, very quick to get that data back out. Obviously, that's the purpose of this whole process is actually to do this, and on some level to you know, either take the load off of your database if you're using it for search, or ultimately if you're using it for the aggregation. Again, to take advantage of the way in which Elastic can take that data out. Now, Elasticsearch is very, very fast, you know, even with, you know, very, very large volumes of data. It's also possible for it to handle a wide variety of different data types, and also have those different data types allocated into different silos. And so this means that you could have one environment and one system where you're storing all of this information in, and you know, are able to take that data out, organized according to these individual buckets. And you can also use those individual buckets in order to put that information in and combine a wide variety of information. So again, going back to that searching example I was giving just earlier, if you put a lot of data in and you put, you know, website information, maybe you know, you're adding in, you know, extensive textual information, you're adding in structured data about specifications and other items, you're adding in descriptions, maybe you're even putting reviews and other elements into there as well. You can put all of that information into Elasticsearch and combine it all within one of those single buckets, and then are able to pull that information back out according to that to that basic structure. Elasticsearch is also easily scalable, which is obviously where the Elastic comes in, but it's also able, through the search mechanism and its ability to aggregate and organize that data, to do analytics. So if you're storing a lot of information, you know, say logging data, etc., it can be a very efficient method to get it into Elasticsearch and just update the information into Elastic as quickly as you possibly can, and then use that and the searching mechanism and algorithm which is underneath within Elastic in order to be able to extract the information back out. Now, obviously, if you think about that in the context of you know, how we would ultimately use that, say within a replication environment, I mean, you can consider probably you know, a number of different use cases where you want to be able to combine information. So you could be doing it from the basis of combining multiple source databases and writing that out into the indexes within Elasticsearch. So, you know, if we have a look at this diagram and we consider that the database, the schema, say, are on the left-hand side, and we're ultimately writing that information out into Elastic over there on the right, we could take all of that information and write it into the same index. We could write it into different indexes. That could equally, with the replicator, obviously, we could do a deployment model where actually those are separate physical databases over on the left-hand side, and we're ultimately concentrating that data down into the one within Elasticsearch. Both models are totally totally valid from the perspective of how the replicator is going to work, and also totally valid from the perspective of how Elastic is going to use and ultimately take that information before it writes that out and stores it over on the other side. Now, obviously, you know, there's additional steps required here if you were going to deploy Elastic into your environment, and that's a very application specific scenario that you're going to do there. But the fundamentals and the basics of how you would go ahead and organize and store this information hopefully are fairly clear from that. The great thing about Elastic is very, very quick and simple and easy to get up and running. And, you know, that means that it doesn't take you very, very long in order to get that, to get your Elastic environment up. And because it's got a REST API, it is fundamentally very, very easy to use and access. You can get up, write data to it, extract data from it, you know, within a few seconds, and hopefully we'll see that in the demo, just in the example of how we write that information across within the replicator as we work through. So, how does the replicator work? Well, you know, let's have a look at the basics of replication. Again, some of you may have seen this before, but I always think it's worth just reviewing how we do this. So we extract data from Oracle or MySQL. So we'll do with MySQL first. What we do with MySQL is we extract the information from the MySQL binary log, and we take all of that information out and we put it into the transaction history log, the THL that you see here at the bottom on the left-hand side. And when we were extracting that information out, we pull all of the data out. So all of the row-based data that you have on your information, we pull all of that information out and we store it into what we call a transaction within the THL. And that's a really, really important distinction to understand. There is, we are pulling out information transaction by transaction at a time. Right, we don't do half transactions. We don't take out you know, a semi-transaction and ultimately write that information out. We take out the full information of a single transaction, and we take that information out and store it. And when we store that information, we store the row data. So we're storing precisely what happens on each individual row, and we know the column name and obviously the value of each information. And we also extract the primary key information so that we know how to ultimately apply that over the other side. Now, for us, particularly when we're applying to certain targets, and Elastic is one of them, that primary key information is relatively important. Because obviously what we want to be able to do is we want to be able to make sure that we're updating the information over on the other side, over on the Elastic side. And for that, we need an identifier, a key structure and piece of information as we write it over. I'm going to return to that point because you know, there are some configuration and other elements that are affected by that, and I'll deal in a bit more detail about the Elastic side. Before we get to there, when we're extracting data from Oracle, which is actually what this diagram here is doing, we extract the information from Oracle using the redo logs. And again, same basic principle as we do when we're extracting the data from the transaction, from the MySQL binary log rather, over on MySQL. We pull entire information out of the Oracle redo logs and the supplemental log when necessary, and we pull all of that information out. And we take that information and again we write it out into the THL. Now the important point here obviously is that it doesn't actually matter to us. Once we've extracted the information and we've pulled that information out and we've written it down into THL, that's actually the important step for us. If we've got down to the point where we've taken that information out and we've written it down to THL, once we've got it in THL, we can do what we like with it. And again, with Oracle, you know, we pull out the same level of information. We're going to be pulling out individual rows. We'll pull out the primary key information. We'll pull out everything that we would need to be able to replicate that information out there over on the other side. Now, in a typical deployment model, for any of our deployments, but obviously including this one here that we're talking about with Elastic, you generally have a replicator that is sat on your extraction side, and you have another replicator that is ultimately sat on your apply side. The two of those communicate over a network port so that we can communicate that information, and we transfer the entire contents of the THL, and then the THL is written out over to the other side. Now, in that deployment model, there's a number of reasons why we particularly use that deployment model, but obviously often these things are on completely separate machines. It is very, very efficient. It is very, very high speed. We do talk about you know, real-time data loading, and that's deliberate because we can actually pull transactions out of MySQL or Oracle you know, within a few microseconds and have it transferred and over onto a slave replicator that ultimately applies that over on the other side. Now, when it comes to Elastic, what the replicator is doing is the replicator is taking that incoming information and then using the REST API to update that information directly over into the Elastic side. Now, I should point out, we do actually do a full service replication into Elastic, and by that I mean we actually take transactions out of one side and apply them over the other side. And because of that primary key information, we're able to both insert the data, and we're also, where relevant, able to update and, if necessary, delete the data over into the other side when we do that. So, you know, this is not a case of taking a dump of information out of the database and then applying it into Elastic and then worrying about the fact that something might be stale. No, we don't do that, right? We are pulling out entire transactions, and we will update that information over on the side, on the Elastic side. So when we pull that information out and we apply it into Elastic, so the way we actually assemble the information, that information is written out into Elastic, obviously, as a JSON document. So we take that information, we take all of the row-based information, and that information is placed into a JSON document that gets inserted into Elastic. We'll see an example of a JSON document in a minute. We also include a bunch of metadata within that information that gets put out. And you're actually able to control what that metadata is, but you can include that metadata over in the other side. So we might take out commit time information. You know, we might take out the sequence number information. You know, we'll take out the source table and source schema information, and also write that out into that JSON document. As we write the information out within Elastic, data is organized you know, first of all into an index name. So that's the bucket I was referring to earlier. So we write the information out into an index name, and then you can also organize within that index name the different types. So this is where you would obviously split up by different types, structured, unstructured, etc. However you want to organize your information. I'm not going to go into what that means from the Elastic side, but certainly if you are new to Elastic, please make sure you go and understand the significance of that. The idea is that the indexes contain all of the same information, and then the type ultimately contains you know, more specific types of information within that overall bucket for a particular type. So what we do, because obviously we're taking information from a transactional database, which is generally organized from schemas and tables, over into the other side, we take the information from a single schema or database and put that, and we use that as the index name, and then we take individual table and table names and we use that as the type information within Elastic, and that hopefully you know, organizes the information. That again is configurable. We'll have a look at some of those elements in a little while, but you know, the organization is there by default just so that we can write the information quickly and efficiently over into Elastic. Now you can change the information. I've already mentioned that. In terms of the primary key information, so when the information is written into Elastic, obviously you write it in. I mean, it's a REST API, and so therefore it goes through to standard REST semantics. So you write data in, and it's a, you know, host name, index name, type, and then a primary key, an ID to identify that individual record when you get it over into the other side. That primary key, that ID rather, in the Elastic side, we take that information from the primary key that you have on your source table. So by default, we'll actually take each of your individual primary keys. So if you've got compound primary keys, multiple keys on your source tables in order to identify a single row, we take that information and we use that as the ID, as the document ID, as it goes into Elasticsearch. And again, that's configurable. You can choose how you want to combine that information. We can take that information, you know, and obviously combine it together just as a string. We can combine it together and use an underscore, etc., and pull that information out. Now, we then construct the rest of the document, that JSON style document, again, which I'll show you in a minute. That's actually the next slide. And then just to reiterate, we do fully handle all of the basic operations. When you insert, you create the data. When you update, it updates the existing record. So we use that primary key information, and we use that to be able to update the record within your Elastic store as it goes across. And we can also ultimately go in and delete the record if that's actually what we really want to do when we pull the information across. Obviously, again, it's going to depend on your semantics and your environment within Elastic. But you know, there are some people who you know, want the information to be able to be deleted, because obviously you don't want someone to search for a product that no longer exists. Equally, there are obviously different environments and maybe analytics and stuff where you don't want the data to be deleted, even if potentially a delete operation has come through. Again, that's something that you can configure in the way it operates. Now, if we have a look at a sample JSON document, you can see here now the information at the top. So this is what you get back when you make a REST API call to pull out a single individual record from Elastic. So basically, I've just inserted a very, very simple piece of information here, and that's the content in the underscore source section of the JSON document. So you can see that actually there are two fields there, which are ID and message, which are the original source information, and then you have commit time, source table, and source schema, which are the custom metadata that we add in. The rest of the information that is there is what's returned by Elastic. So you can see that this is an index of test, and this is a type of messages. This is actually you know, corresponds to the schema and the name. The ID is obviously the unique document ID of the item, and the version is a version number. That version number is automatically incremented as the data gets and the record gets updated. So if I was to have done an update operation here, you go over on and have a look on the Elasticsearch side and have a look, and you'd see that the version is now incremented to 2. And that's a very useful thing within Elastic to be able to identify whether data has been updated or modified as it's gone through. And then finally, obviously, found is true is just an indication that, yes, we've been successfully able to find the record within Elastic. Now, I said there were some customizable elements. The Elastic environment is different enough from a typical transactional database. It's very, very difficult to go in and say we're going to guaranteed use transactional semantics in order to be able to structure this. So what we do is we allow you to customize certain elements as they go across, so that you can get it to more closely manage, mirror rather what it is you have as your particular environment. So you can configure how that operates. You can configure how the ID, how the document ID obviously is handled. So you can specify that on the the primary key information, primary key separated by underscores. So if you've got that compound key, you get it. You could also go to the point of actually also having the schema and the database prefixed before the individual ID. So if you were writing it in and you were organizing it so you were writing it into one single bucket, you obviously might want to be able to use the document ID to have the table and the schema embedded alongside the primary key. And then again, you can have that separated by underscores if you don't want it to be just one big long string. You can configure whether to include the metadata. At the moment, we do the commit time and the schema and the table source information. That commit time, by the way, is the commit time when the transaction was originally written on the source database. So that information is tracked and available within the THLer standard. We just use that as another reference point to be able to put it in. Then you can configure whether you want to actually act on, respond, etc., to delete and update errors. This is a good way for you to be able to handle. Maybe you deliberately don't want deletes to operate, or if a delete should fail for some reason, you don't want the replicator to stop, right? So consider a scenario where maybe you are replicating data into Elastic, but maybe you haven't originally seeded the information before you started. So a delete operation comes in, and the delete operation comes in over on the Elastic side, and it tries to delete a document, and it says, but I don't have a document like that to delete. We trap that typically and say, hang on a second, that's a potential failure, because from a replicator perspective, we are trying to make sure that we replicate data in an efficient manner, and we get the data and the stability and the availability of the data is correct. So ordinarily, a delete failure like that would actually be an indication that there is something wrong. So ordinarily, we would fail. You can actually configure that and say, no, I don't care if the Elastic side says, oh no, hang on a second, that delete operation didn't work because the original document couldn't find. You can ignore that. You can also go in if you wanted to, and obviously, ignore deletes and ignore updates. And in fact, we have standard filters for that. We also have standard filters for being able to do things like change and rename table and schema names as the data goes through. And that could be another way in which you could change and organize how that information gets updated and inserted into the Elastic side. And then, you can also explicitly set that within the replicator and within the Elastic applier. So if you wanted to be able to take that information and write that out into a specific index and type as it goes through, irrespective of the fact that it might have come in from a variety of different tables, we can do that. And then lastly, when you take that information and you ultimately write it in, there are times when you want to be able to use let Elastic just create its own self-generated ID when that information gets across. This is a relatively specific use case within Elastic and Elastic environments, and it does change, obviously, some of the semantics within the replicator. If you choose to go with a self-generated ID, we can't then update that information on the same basis, because the self-generated ID, we have no idea of knowing what the self-generated ID is for the source information as it goes in. But if you are using Elasticsearch for doing analytics and for replicating the data across, quickly and efficiently, and into your target system for the purposes of analytics, whether it's log data or other, You know, you probably don't care necessarily about updates and deletes. In fact, you may not have updates and deletes. You may just be dealing with inserts, in which case sometimes it can be quicker just to let Elastic go ahead and handle the creation and the generation of the ID as it goes across. So those are the customizable elements. They're all organized through properties at the time when you update and install the replicator through TPM. So let's have a quick look at a demo. And, you know, I'm not going to do an extensive one for this one. This is obviously our introduction to how we might use Elasticsearch. So, you know, it's going to be very, very basic. We're just going to go through and have a look here at being kicked out of my machines. So, you know, we're going to go in and just, I'm going to go in and create a record on one side. And I think we might be all right. I'll see if I can also update a record on one side. And then you'll be able to see how obviously that information gets replicated over here on the other side. Let's just have a look. And yeah. So let's insert some information. I was going to use a pre one, but I don't have one. Insert into message 2 values. So we're going to insert that. Let me just have a look and see what's in this table. So you can see we've actually got a fairly basic table. So this is ID number 4. This is the information. So left-hand side here is my MySQL database. I'm taking this information out. You know, so ID number 4 is the one that we've just got in. So I'm just going to use curl here as a very, very simple way of getting the information back out of Elastic over here on the other side. And if I take the information, you can see when I pull this information out, data has already been replicated, obviously, in the background. 2 replicators are already up and running and handling the process in the background. You can see here that we've got the information. We've got the original source information. We've got the commit time. We've got the source table. We've got the record replicated basically over here onto the Elastic side. Now, if I change this message equals 4. Oops. So now I should have updated, obviously, that content. If we go in and have a look at the same record over here, you can see that, you know, we've updated the record. We've done a full update here. We've now got goodbye Elastic. You can also see, by the way, I mentioned the version metadata that gets written by Elastic. You can see that the version is updated over here on the other side. So again, you know, we're writing the information over here on the left-hand side. Excuse me. We're writing the information in. We're getting the updates. It's being reflected very, very quickly over into Elastic, and we do write that information out into Elastic very, very quickly. I will just, in fact, let's just do that now. If I do a status, you can see, you know, the applied latency here is 57 milliseconds. So this is 57 milliseconds is, you know, how long it has taken us to extract it from the MySQL side and ultimately write it into Elastic onto the target. So you can see that is remarkably quick to be able to get that full replication. So what you could obviously do from you know, a deployment and application perspective, you can see how rather than having your application update your transactional database and then update your Elastic environment with the same information, all as part of the transaction in inverted commas within your application, within your application stage, you can lower that down to, I'm only going to write into my transactional store, and then I'm going to let the replicator replicate that data over into the other side. And you know with the replicator that data is going to be replicated over and quickly and efficiently. You know, 57 milliseconds, I'm running 2 VMs on my laptop. You know, it's going to be obviously a lot quicker in a more powerful environment. I think these machines have only got, you know, 2 CPUs and a relatively tiny amount of RAM. It's going to be quicker in a bigger, more powerful environment. So one last thing, let's just where ID equals 4. And then if I go in and try and get that, you can see that obviously now I've deleted it over here on the left-hand side in the MySQL. And if we go in and have a look here, you can see that obviously it's not now found is false, right? We've deleted the ID over on the other side. And like I said, you know, these things are configurable. You know, you've got access to all of your standard filters within the Replicator environment. So everything that you would ordinarily be able to do, you can do here: formatting, reformatting, etc., massaging the data, renaming components, you know, even changing, reformatting the content of the individual rows and the individual fields as that data gets replicated and moved across. Now, future direction, what are we doing? We are doing lots with a Replicator, you know, last year, 2017, was a really busy year for us. We added all sorts of things, including obviously the Elasticsearch applier. We also have the Kafka applier. We're also working on, you know, trying to improve the overall environment. So we have, you know, DDL translation tools built into the Replicator now, so that you can more efficiently move data between different data types. We are also trying to work very hard to make sure that we handle a variety of different target types and structures and stored information over into the other side that more closely match what people are using. Again, with Elasticsearch, you know, there's a limited amount to what we can do in terms of how we organize and store that information, because we're kind of trying to put it in a format that is going to be compatible with the Elastic environment in general. But we will probably make some tweaks and changes there and try and improve how that data gets organized and structured. That might mean that we change the format maybe of the metadata fields. We add more metadata fields. We add more information. Something that has come up recently, for example, is being able to identify whether all of the different rows that are being updated. So, you know, if it wasn't clear from that example, by the way, if you do a multi-row transaction within MySQL, when it gets replicated over into Elastic, we take each individual row and update a corresponding document, create, update, etc., a corresponding document within the Elastic search system, right? We don't take one transaction and you've done 30,000 rows, that gets written as one row out into Elastic. That would get written as 30,000 individual documents out into the Elastic side. So we're taking that information and doing that effectively. We may take and change how that information is represented and how that information is organized in order to make it a bit more compatible. We are trying to work on this system at the moment whereby we know which records were part of a single transaction. We've done that specifically because of our Kafka environment, but I could actually see the same thing maybe being useful from an Elastic environment if you were doing analytics. So identifying whether, you know, an individual record was updated with other records as part of a transaction, we could add that information in. And we're also trying to make sure that we build up this kind of standard set of tools for data combination and concentration, so that it is more efficient and usable for analytics style environments. I mentioned the DDL translation and integration. Be aware there are certain things which obviously don't work, and obviously, you know, Elastic is a slightly different environment anyway. So certain things don't just make sense in the other side. But be aware that at the moment, certain operations don't get relayed through to Elastic because we don't actually get the information in the same way. So truncate, for example, if you're truncating tables, that doesn't get reproduced in Elastic properly because we don't identify the individual truncate. We don't identify the individual rows. That's something that we'll add, as part of our DDL integration. We'll be able to go in and equally, Elastic automatically creates those indexes for you when you go in and create the information. But what happens if you drop a table? Well, at the moment, nothing happens on the Elastic side because we don't identify the drop table and then actually drop the full index within the Elastic side. And again, that's something that you would probably want to control anyway. And that's something that those DDL translation tools enable you to do. They enable you to handle that. No, I don't want to handle a delete. I don't want to handle a removal or a creation of data or a change in a structure of data. Equally, and then again, this may or may not ultimately be applicable within Elastic because it could be an expensive operation, adding or changing fields and seeing whether that information within Elastic, in a typical Elastic environment, you might just say, oh no, we just don't update that field information. And then, like I said, improvement to the data structures, improvement to the record metadata, doing what we can in order to make that information over on the Elastic side more efficient is obviously something that we will be working on and trying to improve. If there's something specific that I haven't mentioned here, or you want to have a look into Elastic, then please feel free to get in touch and ask questions, make requests of me. So where do we go next? I'm afraid I'm over time. I'm not going to be able to take any questions today, but if you have got a question, you have asked a question, we'll answer those and put those in a blog post after this webinar. If you are interested in what you see, you like what you've seen with the Elastic applier, then please get in touch. Whether that's get in touch with me or get in touch with the sales team, we'll be able to talk to you about it and talk about how we can help you with handling that replication of information into your Elastic environment. You've got the information on here. Go ahead and read the documentation. Go and have a look at our other webinars and our other training sessions. We have a webinar and a training session every week. So there's plenty there for you to go and have a look if you want to understand how to deploy a replicator, how to get it up and running, how to get it set up so that you can extract out of Oracle, MySQL, etc. There are various training courses, etc. for that. Please go and have a look. You want to get in touch, my name is MC Brown. You want to get in touch with me, you can see my email address is on there right now. Please feel very free to get in touch and ask any questions. Otherwise, thank you very much for attending the webinar today. I hope you found it useful and informative, and we look forward to seeing you on the next one. The next webinar is in a couple of weeks' time, and we'll see you there. Thank you very much, everybody.